Okay, ready to start. Ready to be engaged. Here we go. So we've talked about piecewise linear functions, right? So a piecewise linear function has kind of two aspects. A function has a constant rate of change, but then it has a different constant rates over different intervals. So that should be consistent with the way you think about a piecewise linear function. Okay, so here's a graph of a set of points. So maybe just take a moment, take 30 seconds. In the context of constant rate of change, what can you say, or what can you deduce? Or what's everything you can talk about this graph in the context of, we're talking about constant rate of change. So talk to your tables. What could you say about this in terms of constant rate of change?
Yes, it is the same.
I mean, unless it's like changing, unless the rate of change is so small that we can't see it actually changing.
Oh, sorry.
Well, no, that's what I'm saying. Like, it's so tiny. Yeah. I seriously doubt that.
I mean, like, I'm not like upset,
Really little
but...
lines that are just slightly just so small.
Yeah, well... Oh, I'm so used to it.
Oh, we don't even know we're five.
But we don't know what F is negative 2 is. Oh, when F is.
Okay, so that's the only thing.
Did you hear what she said? She said, yay.
Also,
I didn't hear a tremendous amount of math conversation from this table, but if I'm honest.
Because that was the first thing you talked about. And then you changed it.
We're looking at it like it's a
The
line.
first thing was not about math, I remember.
Oh, the first thing.
The first thing. Yeah, way first thing.
Are we trying to get that as a rate of change? What rate is the same as every other point on Am I making pick one rate because of the change in x from 0 to 12 rates? That's why it's 1.
Okay, so how about this right here? Alexandra, just name one, say one thing you talked about at your table about this set of points in the context of constant rate of change.
We said that as x increases by 1, the value of y increases
By what?
by 3 times as much. Like,
So-
for every increase in
For-
every 1 increase in x, y increases 3 times. Oh, sorry, by 2.
So is the increase in x, so you're saying for every increase of x, y increases twice as much. But then you were also saying the increase in x was 1. Did you mean to say any increase in x or an increase of 1?
Any increase.
For any increase in x, the increase in y is 2 times as much as the increase in x. Okay, good. What did you guys say back there?
Same thing.
Anything else?
Yeah, we said that rate of change, that relationship is true for any x.
Okay, and that's true for any x.
A little caveat there, for any x within the interval of about negative 1.5 to 1.5.
Okay.
That's all that we usually do.
So for any x in the interval from 1.5 to, or negative 1.5 to 1.5.
The rate of change is
Okay, and so in that multiplier, she said that the change in y is 2 times the change in x, and so then you're saying that 2 is, you said that what is the 2 then is constant rate of change,
y
right?
with respect to x.
Right, okay. So we have a constant rate of change of 2, y with respect to x. Okay, so this would be in the realm of looking at a quantity. So if we had a quantity increasing at a constant rate of 2 with respect to some other variable, how is that quantity being represented on this graph? So We're saying one quantity is changing at a constant rate of 2 with respect to some other variable. How is that quantity being represented on this graph? Yeah?
The amount of the quantity is the y value of the ordered pair.
He's saying it's the y coordinate. The quantity would be the y coordinate. So quantity is increasing at a rate of change of 2. He's saying that quantity is the y coordinate on the graph. Agree with that? Michelle, you don't look certain about that.
I'm not sure I understood the question when you said the question.
So constant rate of change means that something's a constant rate of change of 2 means that some quantity is changing twice as fast as some other variable. So that quantity that's changing twice as fast as some other variable, how is that shown, displayed on this graph, represented on this graph? So
So and then he said the y value.
he's saying that's the y value.
Yeah.
Agree with that?
Wouldn't it be the change in y value though, not just the y value?
The quantity is the change in y.
That's the change in quantity.
So is the quantity the y coordinate or is it the change in the y coordinate, the quantity?
Can you answer your question again?
So we kind of almost come to consensus that the quantity we're talking about that's changing at a constant rate of 2 was the y coordinate. And then Jason said, no, it's the change in y that's changing at a constant rate of 2. Right? Did I interpret that correctly? What do you think, Catherine? Or Angela? Go ahead.
Well, what he said, like if the change in y is changing, that's more of like, so then it's not constant because your change is changing by 2. So then it has to be just y because y is changing.
Okay.
I agree. I think that change in y is like an exponential function.
I wasn't saying the changing in y.
Not constant rate.
Changing.
What's that?
The change in y is a constant rate of 2, I was saying.
Oh, okay.
With the quantity in focus that's changing at a constant rate of 2 is represented as the y coordinate. You good with that? Yeah. Yeah, go ahead.
So you're saying that y is changing at a constant rate of 2?
Are we saying that? We're saying y is changing at a constant rate of 2 with respect to x. Yes. That's what we're saying. With respect to x. That's what we're saying. Okay, so this is like the quantity graph, or the amounts graph, and it's displaying a constant rate of 2. There's another way to graph this that displays a constant rate of 2. And that would be if we made the y coordinate the rate of change. And then that constant rate of 2 would show up as a constant value of 2. You see that? So these are showing the same, there's 2 different ways to show a constant rate of 2. So for any change in x, your rate of change is 2. Over every interval of length delta x, you have the rate of change is constant at 2. Well, same thing here. The change in y is always 2 times the change in x for every delta x. Okay, so that's 2 different ways to show a constant rate of 2. The quantity graph and the rate of change graph. Okay, any questions about that? All right, so here's a rate of change graph. So the y-axis is showing the rate of change of some quantity with respect to x. Can you sketch the quantity graph? Go, sketch what the quantity graph would be for this rate of change.
We need masterpiece.
Like yesterday. Rate of change graph.
I agree with your first graph, but I also agree
was just missing it again.
Are the
Face me.
You can make us
or not are
There's no R.
no, yeah, you're right. It's the F.
There's no point. You know,
You would need to know F of 0 to be able to scale.
well,
We just know that I have that.
Yeah, but you can only see what's in F of 0. You start at that one point.
no, because, for example,
Oh, yeah, you would have to know the limits. Coming from the left.
well, let me use zero. Just,
Yeah.
Okay. Okay, so I saw a lot of this. I saw a lot of these. So what are we saying? When x is less than 0, the constant rate of change is -1. When x is greater than 0, constant rate of change is 1. Okay. Anything to add?
I know that you can also have the possibility where the two lines are not necessarily joint.
Okay. And why is that, Catherine?
Just because the only thing we know is the rate of change. We don't know how those, where the points on the lines that gave us those rate of change came from.
We don't know where the y-axis are,
Okay.
so we don't know exactly where the initial, like, where they meet, or if they meet at all, but where they cross the y-axis.
Okay. And so what is that right-hand graph again? What is it? What's the y-coordinate? Some value of some quantity, right? So we don't have any information about how much we have at any x value. All we know is the rate of change. Right, so there's many possibilities, right? So maybe it's this. Maybe it's this. Okay, so yeah, so that we don't have any information about at an x value we have this much stuff, right? This much of that quantity. We just know the rate of change. So, right, any vertical translation of either piece is going to be possible. Okay, any questions on that? So the idea of we can show a constant rate of change in two different kinds of graphs, where the y-coordinate is measuring the rate of change, and then if it's constant rate of change, we'll get a horizontal set of points, right? Horizontal set of points. And then if it's on the quantity graph, we're going to get a linear function showing that constant rate of change. Okay. So let's talk about taxes. Let's talk about taxes. So this is a little piece of a tax table. Okay? And so how does this work? You go, if you are, if you made $26,400, you're gonna, or say 26,425. You're gonna look right here, and you're single. It's gonna tell you how much tax you're gonna owe on that amount of income made if you're single. Okay. Okay, but where do these numbers come from, though? So what's the basis of the values of tax in this table? Where did that number 3545 come from? How is this table generated? Okay, so let's talk about that. So here is what's called the function named tax rate. Function named tax rate. Okay, and so you see that it's a piecewise function. And so what are the independent and dependent quantities of this function?
Income is your independent.
So independent income. So looking at those ranges of x values, that seems like a good guess, good educated guess, and it is. So your independent variable here is taxable income. So after your deductions, after all the different rules about taxes, you get that amount of your income that is taxable. Okay, and then what about the dependent variable?
Tax.
So what is the dependent variable in this function? Looking at those outputs. Tax rate for the year. Well, yeah, but it's still that we can define that quantity even though it's different value for different values of x. But we can still define the meaning of the quantity. So that's what just the meaning of it.
It's your tax.
It's your tax. That would be nice. Not your tax. I paid a quarter in taxes this year.
That sounds about right.
Taxes no vote for me.
Taxes owed.
Our education system is
Okay, this can't possibly be your tax due. Can't be your tax due. These are all less than $1, right? They're all less than $1 if it's a month done. So what is it? So percentage of your income. Okay? It's like a percent of your income as a decimal. Okay, is it a rate of change function? Is this a rate of change function? Okay, but is it rate of change? Is the dependent variable, is it a rate of change? So we're getting this 0.25, 0.28. Is that a rate of change or not? Paul, you're saying yes. How are those numbers a rate of change? Like 0.28. How is that a rate of change?
Because between, say you're making $82,400 and between $171,000,
Okay.
like the amount of money that you're being taxed on, if you're finding the rate between any two values between there, you're going to be getting 0.28 as your rate.
Okay. Somebody else. Why is 0.28 a rate? Tony.
For each bracket you have, so the first one 0 to 837. For every dollar you increase in your income between that bracket, you increase your taxes by 10 cents. Next bracket, you increase your taxes by 15 cents for every dollar increase.
Okay, so you're saying for every dollar increase, your tax goes up
15 cents, or depending on where your bracket is.
15 cents.
In the second.
Okay, are we? So we're saying that this is a rate of change. These are rates of change. When you said that, when you defined the rate of change, Alexandra defined the rate of change of 2. How did she define that rate of change? What did she say?
For every change in x value,
Yeah.
y changes by 2.
2.
In this case, for every change.
Wait. Y changes by not by 2.
2 times.
2 times the change in x. So does that apply here? Where change in x is say 0.33. Is your change in output 0.33 times your change in x? Does that apply?
Like every dollar is taxed by that.
Okay. Make sense? Yeah. So this is a rate of change function. It's a piecewise constant rate of change function. Okay. So how much tax do you pay on $50,000? How much tax do you pay on $50,000? Or how would you figure that out? People are saying $12,500. Nick, agree with that?
Yeah.
Which is found by how?
0.25
0.25 times 50,000. Okay? All right, so let's hold that thought for a sec. So we got this function. The input of this function is your taxable income. The output is the percent of your income or the tax rate for that amount of taxable income. So here is another function called tax. Okay, so what is the independent variable for this one? Same? Taxable income. Okay, and then dependent. What's the dependent variable in this function? Tax due. How much do you owe in tax? Tax due in dollars. I should have put in dollars for both of these. Okay, so you said that the tax on 50,000 was 12,500. Show me how this function gives you that value. Go. So find the tax on $50,000 of income according to this function. Work together. Go. Talk it out.
Yeah, it's a change. 30, yeah. So that's 45 because that's the way it works. Because pieces of your income. So like for the first $8,000 you pay some, and then the next whole $20,000 you get taxed on this rate, and then the next for the next rate. Oh. Let it go deeper.
So this is what I mean, like taxable income, meaning this and your
Way easier. No, actually, I'm in favor of a flat tax.
Whatever makes it.
Because they already know
Really for president.
because that's just the tax on
So,
50,000, right?
yes.
Okay, I think I have it.
I just did the 0.25
I have
times.
large numbers.
But they
I just got
they
that.
just divide like that because they already know the answer to it. Just whatever else you think.
question. It says that if x is less than or equal, it just says if x is greater than 34,000. So that 0.25 doesn't apply if you make exactly 34,000. What applies to exactly 34,000 is the 0.25. Feel me? Like I get what you're saying. I'm just.
Yeah, but then you make one of them.
basically.
Right, but if it's saying like the tax of 34,000,
Yeah.
technically according to this, the tax of 34,000 is 20%.
Gone to 65.
Oh.
Which is
You would have
Yeah, we made it.
41,000.
I was looking at Robo.
Good, good. 8,081.
So some of you are getting something. The tax of 25K. What was it?
8,681 and a quarter. Well,
Yeah, it's
you asked us for 50,000.
very
What?
interesting.
Oh, this side 50. I said 50. Just misread it.
Interesting.
Typo. There you go. Better? So you like your result better? Yeah. Why? Because you. Yeah. Okay. So yeah, it's not 12,500. So somebody knew what's going on here. Why wasn't it 12,500? Nick wants to. Yeah. Go ahead.
If you did it in the previous square where you have a constant rate over a certain interval,
Okay.
anytime you have the giant, like, you have the break in your rate, if you make even $1 more than that break, you're going to be taxed more than if you were behind the break.
Okay.
Just on the one. No, it's on all of your money.
No, the other block was previously taxed. And that
No,
one
no,
block-
In this one, he's talking about in the old.
The old one.
Oh, in the old one.
Yeah, so this new one is better for everyone overall.
Wait. So new and old?
So if you just did your taxes based on the last one,
What was the previous function? That was the tax rate function. What is the rate from 0 to 8375? And what is the rate in the next bracket? What is the constant rate in the next bracket? All right. So is it old and new? They're both at work here. The first one was the rate of change function, and then this is our quantity function. Okay. So everyone see what's happening. So you have a revelation?
Because it's the rate, because the tax of those values is always going to be a constant amount. Line.
Okay. So somebody knew why was it 8,681 and not somebody else, not 12,500 million?
The way that it works is like your first 8,000 some odd dollars is taxed at a certain rate, and then the next $20,000 after that is taxed at the little bit higher rate, and then any money after that is taxed at a higher rate.
Okay. So yeah, the different amounts that you make along the course of the year are taxed at these different amounts. You don't, if you make 50,000, you don't pay 25% on all $50,000. Okay, so then that 0.25. If it's not the amount, the rate of change on all $50,000 that you make, how is it? What is it a constant rate for? What is it a constant rate for? What's that?
How far away your income is from the left of X. From the beginning of the interval.
Okay.
So like if I make, 20 or 10,000 more than the people in the left bound of my interval, I'm going to be charged a higher rate on those 10,000. But I'm going to be charged the same rate on the previous whatever thousand. 82.
Okay. Anyone else?
It's like how deep you are into this tax bracket. You can charge a higher rate on that amount.
I would just say the 0.25 is how much you're taxed, or the rate of what you're taxed if you made more than 34,000.
Okay. More another way to think about it, it's the tax you pay on the next dollar that you earn, or the current dollar that you've earned. Did you buy that? So whatever the next dollar you're gonna earn, if it's the 101,000th dollar, then that dollar is gonna be taxed at what rate? The 101st, the $100,001. It's hard to say. What I mean to say is this dollar right here. Yeah, the 100,000. That dollar right there. You're gonna be taxed at a rate of 0.28, 28 cents on that dollar that you earned. That's what I meant.
But isn't this is just a specific case? Like, why are you saying 100,000?
I just picked an example.
Right. But shouldn't we talk about like the left bound of one of the intervals?
No, I'm asking how are these numbers rates of change? What are they a rate of change of? If 0.25 isn't what you pay on $50,000, then what is 0.25? What do you pay on that? Or what?
Every dollar that is in.
Right. Every individual dollar, right? So like the next dollar, right? You're gonna pay 25 cents on the next dollar in that bracket. In that bracket. Yeah, 20.
Just gonna bring it down, but for every change in X past that left X, which in this case would be given, for every change, your change in tax is 0.5 or 0.25.
Times that amount of change.
Times that much.
That's right. Okay, so this idea is called this is a progressive tax. We have a progressive tax system in our country. Okay. All right, so let's talk about. We already talked about that. We know the input, the independent quantity is taxable income. Output is tax due. Okay, so now you've got some questions here. What's the structure of this function? What's the form of each line? And then let's look at line 3. And we want to look at the meaning of each of those values that you get. If you were to see that as a value, as an amount of something, it's an amount of what, right? So what would each of these as a imputed value represent in that third line? So think question number 2, and then work through these 5 expressions, the meaning of each of those expressions in line number 3. Okay? Did you have a question, too? What's the structure of this function and the form of each line? Tell me.
So the structure of the function is the amount tax, it's a piecewise gain function. So
Okay.
Regardless of where you're at in the function, it goes backwards.
Okay.
So the higher that you are, if you're on line 4, it's earlier, then you gotta go to 3, then 2, then 1.
Okay.
And that's where the chain comes in. And then it goes rate, amount taxed at that rate, and the amount taxed at the next rate is the form that the.
So do you recognize that form at all? Do you recognize that form?
Yeah.
What is that?
So you said you recognize that form.
So we talked about that before. Natalie, do you recognize that form? Have we done that before? Point slope, right? This is point slope, form of the line. That's the we talked about that, and then you did some work with that point slope form. Okay, here we go. X minus 34,000. What is the meaning of X minus 34,000?
I was thinking maybe that your income.
Yeah, but then okay. And then what does that number mean? When you do that subtraction, you're going to get a number, and what does that number mean?
That means that you're gonna put that number in. You're gonna use that number to calculate your tax, right?
Yeah, but what does the number mean? Casey?
It's how much money you're going to be taxed at that current tax rate.
Okay, so it's the amount of money you'll be taxed at the current rate. Good. Okay. What's that?
What do we need current?
So in that bracket.
In that bracket.
Yeah. So at a point like between 34,000 about X changing, whether it's time or not. X could be changing, and we can talk about the current value of X. Whether X is a time quantity or not. Yeah. Nydia, how about 0.25? What's the meaning of that? Okay, good. It's the rate at which your tax is changing. Okay? And then 0.25 times X minus 34,000. Veronica. Tax due on the money in that bracket. Cool. Okay. And let's see. Yeah. Tax of 34,000.
I think that's the taxes that you paid on the money not in that bracket.
Taxes that you paid on the money not in that bracket. Okay. And then Alex, the last one. 0.25 times X minus 34,000 plus tax of 34,000. What's that?
The total taxes due.
Total taxes due on how much money?
That's right. Amount. Oh, yeah. On X.
On X dollars. Total taxes due on X dollars, where X is in that bracket. Okay, questions on these questions? Any clarifications? Are we good? Okay. So let's start. Now, this was just all to get you oriented with how the tax function works. So let's kind of talk about it. Oh, so here's what I said. Number of dollars earned above 34,000 or in the 25% tax bracket. This is the rate for that bracket. The amount of tax owed on dollars earned at that rate. The total tax due for the first 34,000 and the total tax owed on all X dollars. Okay. Any questions? All right, so here are two graphs related to what we just talked about. On the left is y equals tax rate, and on the right is y equals tax. So those are the two functions that we've talked about. And so here's the graphs emerging as your taxable income grows. Okay. Okay, so we're going to just do like 30 seconds on each question. Ready? So here's question number 1. Go. Where can you see Cerebral's taxable income growing? So just 20 to 30 seconds on each question. Go. Okay, Jessica, tell me, where can we see Sarah's taxable income growing? So you're saying the graph on the right? What about the graph on the right? Where do we see the taxable income growing? Want to pass? Okay, so on both graphs, but where on both graphs? What specifically? Okay, and what is that line along the bottom called? X-axis, right? Yeah. So we're looking at the x-axis of both graphs, right? The x-axis on both graphs. Okay, what does the current value of her taxable income mean when that amount continually changes? Go. What does the current value of her taxable income mean when that amount continually changes? It's a little bit of a trick question. The current value of her taxable income, anyone, what do you think? So, any thoughts? Nick?
Is that her earnings for the year so far?
Her earnings for the year so far, okay? One way to think of it. Other thoughts? So in order to talk about a current value of her taxable income that's increasing, you have to pause life. You have to stop it from changing and pause it. And so when you pause it, then you get some current value that you can talk about. So I'm looking at what 44,000 or something like that. That's where I paused the animation. Okay. Number 3. Where can you see Sarah's marginal tax rate for the current value of her taxable income? Zaying, where can you see her marginal tax rate for the current value? Zaying. See. Zaying. Can you answer this question? Where can you see Sarah's marginal tax rate? Okay. So if I were to pause it right now. So now her current value of taxable income is something like 23 or 23,000. Where would you look on this screen to find the current marginal tax rate? Right. Yeah. And so you're looking at the y-axis on the left graph, right? Yes. The y-axis on the left graph. Okay. Where can you see the amount of tax Sarah owes for the current value of her taxable income? Dottie. So you're looking at the blue line to see the amount of tax that she owes?
Yeah, so you're looking at like that blue line is over. So if you were to stop it, go over to the y-axis.
Okay. Yeah, so it'd be the y-axis on the left graph for the current. Yeah. What's that?
You mean the white coordinate?
No, but where would you look to see the amount?
Oh, okay.
Where would you look to find that amount of tax due?
On the right graph. Yeah, the right graph.
I'm sorry, I was thinking right, I said left. Okay. Where on the right graph would you look? The y-axis. Okay, the y-axis on the right graph. Sorry, I misspoke. Okay, what does a point on the right-hand graph represent and on the left-hand graph? So, go. I'll give you a chance to talk. There. It's important that you can articulate this well. It may seem easy, but can you articulate it well? Because my students cannot. We have to practice. My pre-calc and calc students. Okay, Rochelle. On the right-hand graph, what does this current point here? What does that point represent? That point.
So it, for that current income, whatever 41,000,
Okay.
it would be the exact amount of taxes.
Right. So it's a corresponding values of two quantities. In this case, taxable income and tax due. So for 41,000, it's the corresponding amount of tax due. That's what that point represents. Okay. So what about on the left-hand graph? Who hasn't gone in a while? Yeah, Catherine.
It's the current taxable income and the corresponding marginal tax rate.
Right. That point is the current taxable income and the corresponding rate. And that rate is for, we think about that rate, what is it, 0.25? That's like the rate on the next dollar, right? It's like the rate on the next dollar earned. Okay. Why does the left-hand graph jump discontinuously? Why does the left-hand graph, Paul, why does the left-hand graph jump discontinuously?
Because there's no tax rate for, say, I can't remember where that first break is, but it's like $8,300 some odd dollars.
Okay.
But there's no marginal tax rate of 0.12 or 0.13 or anything. There's only a marginal tax rate of 0.1 for the certain interval less than 8,300.
Right.
0.15 anywhere greater.
Right. At the end of that first interval, that last dollar you're going to be taxed at 0.1, and then the next dollar you make,
It's taxed at 0.1.
immediately taxed at the higher rate. And why does the right-hand graph change slope abruptly?
Well, the next cent.
Go ahead. What?
The next cent on any money past that threshold.
Yeah, right. Yeah, so you could even go smaller than dollars. That's true, right? Yeah. Why does the right-hand graph change slope abruptly? Amelia.
Because the rate of change changes abruptly.
Okay.
Like we said, the rate function itself, the value changes abruptly.
Right. Yeah, it's like the same question, right? It's the different ways that rate of change is shown on the two different graphs. So if it makes an abrupt change, a jump in the tax rate, then that's going to be shown as a change in slope on the tax function. Okay, in what way does Sarah's tax due accumulate, and how is this reflected in the graph? So this is for discussion. In what way does Sarah's tax due accumulate, and how is this reflected in the graphs? Graph or graphs? What's that? Yes, it's discussed in the table, that's right.
She has to be less end of that bracket, the end interval of every bracket, rather than the rates from the bracket that you're on. I don't want to know.
Well, what happens?
Right, but
I didn't know that.
well, okay, I see what you're saying. I see what you're saying. If you assume the initial.
Okay, Brianne. What did you guys talk about at your table?
We talked about the right graph.
Okay, the right graph?
Even when the marginal tax rate changes, so the slope, you don't start back at 0. It just keeps adding where the other one left off,
Okay.
showing the accumulation. But we couldn't really see it on the left.
Okay. All right, so how is it that you said you see it adding on the right. How is it that you see it adding? How is it that you see it?
Like starting where the other one, like the other rate, like stopped.
Okay.
Instead of starting back at 0 for a new rate.
Okay.
Like,
What we were like saying.
Yeah, go ahead.
That, like within each bracket, like you're accumulating some amounts due.
Okay.
And like that
Okay.
And so you can see that like add up.
Okay. Other thoughts from other tables? What's that? Mary?
Pretty much what we said.
Okay.
Just
How does dust accumulate where you live? Do you walk home one day and is there 3 inches of dust? Over time. What happens over time? What's that? No.
It accumulates.
How? So what does that mean? It accumulates.
Dust adds up to the previous dust.
Right. In big amounts or small amounts?
Small amounts.
Small amounts. Okay, so here we are at 40,000. So when we think about how the tax is accumulating, it accumulates, your tax due accumulates as you make every single dollar, or even 50 cents. They say you're going to make 50 cents at a time. Every time you make 50 cents, a little bit of tax accumulates. How can I represent what I just said here starting at 40,000? So I'm going to make 50 cents more and I'm going to pay a little more tax. How can I represent that? Yeah, Daddy.
I like think that's a little time. So like a little change in your taxable income.
So we're,
like a horizontal line. And then a corresponding vertical line.
I really wanted to make it pretty. Okay, so little horizontal line.
Yeah, and that would be like the change in your taxable income.
One more try. I can do it. This is very slick. Okay, woohoo. All right, and so what do we call that?
The change in your taxable income.
Yeah, or delta x, right? So say that's 50 cents. So that represents I just earned 50 cents more taxable income, and therefore, what happened?
You owe a little bit more taxes, so there's a vertical line, and that's your delta y.
Right, and so there's a corresponding little amount more tax that gets added on to what I had accumulated before. So the blue line, you think of it as it's going up because of for every little amount of money I make, the amount I taxed is adds on to what I made before, and so that makes this rising amount of tax as my taxable income grows in little chunks and little bits. So symbolically, we can represent the I'm showing here a current taxable income of 58,000. Symbolically, we can represent that tax due in 2 different ways. What is one way that we could represent the tax due on 58,000? So maybe talk your tables. Can you think of 2 different ways that we can symbolically represent tax due at 58,000 in light of our conversation about accumulation? Okay. How can you represent that amount of tax due?
Tax plus 58,000 plus tax 58,000 tax rate. Or we can just write tax from parentheses 58,000.
So 2 ways to think about this tax due on 58,000. Who thinks they can talk about one of the 2? What's one way to think about tax due? Tony.
Just put in 58,000 into the tax function.
Okay, yeah. So exactly. So it's like you made this much money, you owe this much tax, right? It's going to be the value of the dependent variable when the independent is 58,000. So that would be as a total amount of tax. Just boom, for 58,000, this is how much you owe at the end of the year. And so that would be, how would that be represented? Tax, yeah, it would just be the function notation. Okay. So sum of what?
Different amounts of tax. So amount of
Okay, but is that how it accumulates? So you're just working and all of a sudden you owe all that for the first bracket and then all of a sudden you owe all this for the second bracket? How does your tax accumulate? Right, small amounts. Yeah, go ahead.
Tax rate of 58,000 plus that base amount for I don't remember where the first bump was, but basically tax rate of 58,000 plus that base amount.
You're still thinking in big chunks.
Okay.
Things don't accumulate that way. Things don't accumulate that way. How do they accumulate? And how can we represent that? Henry, you've been quiet. How do things accumulate? And how can we represent the total accumulation of small amounts of tax? What's that? So what did we do on the last screen? How did we show a little amount of tax accumulated? What did we show? How do we represent it? Right, it'd be the sum up of lots and lots of.
Yep. You just wrote it perfectly.
Yeah, so it's going to be the sum of lots of little. So I would say 50 cents for each 50 cents earned. I like 50 cents better. It's just the idea of it. It's the idea of small amounts of income earned. Okay, that's just the idea. So I could have said 25. We could say a penny. Doesn't matter. But so the point is, we're adding up the changes in Y, each little bit, and then after you've to the point where you've made $58,000, the total tax due would be the sum of all those little amounts of tax that you accumulated along the way. So two different ways to represent the same number.